Today, we are doing proving statements about angles 2.8.
No.
This is our last section in our really fat stack of notes, okay? On Thursday, we will be taking a quiz over 2728, the section we just checked our homework over that we learned last time, and the section we're learning today, okay? Then we're going to start with a little bit of reviewing Chapter 2. On the following Monday, our class after that, we will be reviewing Chapter 2, and on that Wednesday, my dudes, we will be taking our chapter test, okay? If you know that you will be gone on that Wednesday, maybe you're leaving early, because we don't have school that Thursday, Friday, maybe you're leaving early, communicate that with me, because we need to take our test ahead of time, okay? So if you know you're going to be gone on that Wednesday, communicate with me. We need to take your test ahead of time. We can take it on that Tuesday.
Wait, what day do we have school?
Thursday, Friday. Okay. Next week, we do not have school Thursday, it's Friday, okay? It's a fall break, okay?
Let's go!
Where are we going?
Going to
So,
Canada. Getting you a bit. I gotta see
Focus back up here, please and thank you. Let's flip to this page where it says angle proofs reference. Please and thank you. Flip to this page where it's saying angle proofs reference. I'm so tired. Nice to meet you. I'm so tired. Okay, voices back off.
Wait, if I say it backwards, like
No.
will you say
Voices
it?
back off here.
Mr. Kossel, I have a real quick question before we start.
Okay, hey, everybody actually want you to stand up. Everybody want you to stand up.
Man.
Yeah, we need to do some jumping.
Everybody want you to stand up. I want you to stand up, okay?
Ow!
Here's what we're gonna do, okay? I want you to bend down and touch your toes, okay? Imagine bending down. Or right now, breathe in. Bend down and breathe out. Go back up to straight and breathe in. Go back down and breathe out. Back up and breathe in. Back out.
Making me lightheaded.
Breathe out.
It's supposed to be covering his down. I'm assuming. So you
Alright.
no more.
Let's sit back down.
You didn't answer my question.
I can touch my toes.
What's the biggest punishment you've ever given a student?
The biggest one I've only had to go out was I had to take him out to take him to the principal's office when then.
Who was it?
I was personally, it was Steve Neck right now. But I sued Tom. And then I like chased him to the hall because he was trying to make leave.
Did you just tackle him? That's
I super, no. Hey, here's an angle proofs reference, okay? Here's an angle proofs reference. This is a nice candy page for you to look back on. This is a good page to look back on for our notes today and for our homework, for looking over a quiz, for preparing for a test, for the review worksheet. This is a great page to look back on. If I were you, I'd even write like some sort of a star or something like that on this page so that way you know to go back to this one, okay? This is a great page to go back to. Okay? As well as our segment proofs reference we had before. It literally says reference in the name, meaning we should reference back to it. Okay? So here we have listed all of our properties of equality that we've covered before. We have our properties of congruence we've covered. And then we have some definitions, okay? You remember definition of congruence from our segments. That was saying if two segments were congruent, they had equal measure. Same thing for angles. If they have equal measure, the angles are congruent. Or vice versa, the arrow's going both ways. If the angles are congruent, measures are equal. It's the same thing we have for segments. That's not new. We're just saying it's true for angles as well. Then we have another definition. It's definition of angle bisector. Okay? If we recall, an angle bisector divides an angle into two equal parts. Divides it into two halves. Okay? Cuts it in half. So definition of angle bisector. So if we ever see an angle cut in half or cut into two equal parts, we're using our definition to do that. Definition of complementary angles. Complementary means they add up to 90. So complementary angles, meaning their sum or adding is 90. Okay? The definition of supplementary angles, same thing, summary, but instead now they add up to 180, okay? Or vice versa, if they add up to 180, they're supplementary. If they add up to 90, they're complementary. Adding up. So can you have one thing adding up, or does it have to be multiple things adding? things added together. You can't just say, like, your height adds up to this. No, like, your two heights add up to this, you know? Okay? Definition of perpendicular. Perpendicular means they form right angles. Okay? Perpendicular lines form right angles. And we have definition of a right angle is that a right angle has a measure of 90 degrees. Okay? Or it has a 90-degree measure, and it's a right angle. So those are our definitions. If we go right below this, we have more references. We have our postulate. We have our angle addition postulate. It's very similar to our segment addition postulate we covered before. Two parts of an angle ABD and angle DBC, add up to the whole thing, angle ABC. Okay? Then we have some different theorems, okay? I suggest you might want to draw this picture right here for vertical angles. Vertical angles are the angles that make what shape? Are X, very good. Vertical angles make an X, okay? So they're the angles that are opposite each other, they share that vertex, and their sides make an X.
Wasn't this from a long time ago?
This is from chapter 1. If two angles are vertical, then they are congruent, okay? We're applying it now. If two angles are vertical, then they are congruent. That's called our vertical angles theorem. So it comes straight from vertical angles, vertical angles. So if they're vertical angles, we know they're congruent. If they're vertical angles, we know they're congruent. Complements theorems. It's going to be dealing with complements. If two angles form a right angle, then they are complementary. So if you have two angles making a right angle, that means they're complementary. Because what happens if they're a right angle? It's how many degrees? 90. So if the two angles make a right angle, that means they're adding up to 90. That's being complementary. That's a complement theorem that allows us to jump straight to that. We also have the supplement theorem. If they make a linear pair, two angles make a straight line. Okay? They add up to 180. Okay, they are supplementary, okay? Grace, please step forward, okay? Thank you. Okay, then we have our congruent complements theorem, okay? If angle A is complementary to angle B, and angle C is complementary to angle B, then angle A and angle C are congruent. Let me explain that. Okay. Casey, give me a measure between 0 and 90. Between 0 and 90, not including those. Not including those.
Between
Cool.
2 to 89.
Okay? So angle A is 89 degrees. What would angle B have to be in order to be complementary with that? 1 degree. Okay? If angle B is 1 degree and angle C is complementary with that, what's angle C have to be? 89 degrees. To be complementary with this 1 degree. So what do we know about angle A and angle C?
They equal each other.
They're congruent. They have to have the same measure. They have equal measure, okay? So if they're both complementary to the same angle, they're congruent. Now this comes straight from our words. Congruent complements theorem. How many complements do we have? We have one set of complements, two set of complements. We have complements, and we end with angles being congruent. Congruent complements. Okay? See how I'm just going straight from the word? Okay? Congruent complements. Congruent angles come from two complements. Congruent angles come from two complements. Then we have congruent supplements. Same idea. If angle A is supplementary to angle B, angle C is supplementary to angle B, then angle A is congruent to angle C. The only change here is instead of complementary, they're supplementary. So they're adding up to 180 now. So congruent angles coming from two supplements. Supplements, congruent angles. Congruent supplements theorem. Once again, we'll go back to these a lot. Okay? Let's go over to the next page, please, and thank you. Okay? We're going to practice a little bit here, okay? Okay, on number 1, if angle A is a right angle, then the measure of angle A is equal to 90 degrees. On the left, angle A is a right angle. That's a lot of words. On the right, measure of angle A is equal to 90 degrees. That's more math. You have something equaling a number. So we went from words to math. What's a big hint if we go from word to math? From math to words? It's probably a definition of some sort, okay? So to know what definition, we often look at what words are we using. Okay? What words do we see? Measuring angle A is what kind of angle? A right angle. Well, if we go back to our previous page, our angle proofs reference, and look under our definitions, which of these definitions deals with something being a right angle and something being 90 degrees?
Big point.
Definition of a right angle. It's definition of a right angle. It deals straight with that. It says a right angle is 90 degrees. That's what we're saying. A right angle is 90 degrees. Okay? Page. Okay. Here's what I want, okay? You two are working on number 2, number 3, number 4, number 5, number 6, number 7. Don't make me regret this, guys. Put it this way. Okay. Number 8, number 9, number 10. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2.
One, 4.
Yes.
Okay. How? Where's the definitions of? Oh shoot, you're just there.
Okay. If you need help, look at the previous page.
Come in. I didn't listen to what you said.
These will find out number 11.
So if
So I would restart.
you 90 degrees
It's that one segment on
P of you are complementing.
it's the angle addition.
I want you working with your partner, or at least checking with your partner. Somebody hand in a blank homework 5.
JK.
What? Okay. That's quite the weird flex.
Maybe she accidentally No, you can't move.
Yeah, you can.
Do you think it's like
You can do whatever you want.
I do have free will. Means I can leave school, not take it. Free will.
You could, but
There are consequences.
I mean, typically they say I have to be on school grounds. They don't say I have to be in the school building. Meaning I can just go sit on the football field.
Yes.
technically you can do whatever you want.
Go there, just jump the fence, go sit, right? You don't have to be.
Whatever you decide.
Oh yeah,
Okay. Ian and Emily, what did you guys get for number 2? I agree. That would be our congruent supplements there. Hey, if you don't have this one, if you weren't assigned number 2, let's make sure we're doing number 2 right now. Congruent supplements theorem. We have congruent angles. Shh. We have congruent angles coming from 2 things being supplementary. Okay? We have 2 sets of supplements. Then we have congruent. So congruent supplements theorem. Okay? Number 3. Okay? What do we have, Christine and Kale? And not quite, unfortunately, okay? Definition of congruence would be something being equal.
What does
something being congruent.
THI mean?
I agree, okay? That would be our vertical angles theorem. Okay? These 2 are vertical angles. They make that x, okay? Like we drew on the last one, so they are congruent. That's our vertical angles theorem, okay? Skylar and Grace, what do you guys have for number 4? Okay? I'm not quite done. I'm going to disagree a little bit. Okay? We went from math to words. What's the big hint if we go math to words or words to math?
Definition.
It's probably a definition. Okay?
Got that right.
And definition of, well, what are we dealing with? There are
Complementary.
complementary. So definition of complementary.
He got that right.
Okay? You got it right, Skylar? Good job. Got it. Good work. Okay? Definition of complementary angles. We went from 2 things. We went from math to words. Anytime you go math to words or words to math, big hint. That's a definition, okay? Yes. What number 5? What do you girls get?
Congruent. Wait. I have to read it. Congruent complements theorem.
Not quite. Okay, so congruent
What?
complements theorem. Okay. Congruent complements theorem would look like number 2, except for the words would be complementary. Okay, we don't have 2 sets of complements going into that, but instead we have something from a right angle, so they're complementary. If we go back to our previous page, we look under theorems. Okay, we look at our second theorem there. If 2 angles form a right angle, 2 angles form a right angle, then they are complementary. Is that what we have? So it would be our complement theorem. This would be our complement theorem. Okay.
Okay. What is the difference between them? Because they're the exact same thing, except congruent.
Okay, not quite. Okay, so it's in
What's the
the
difference
words.
in that?
I understand what you're saying. In the words, in this they are. Okay, but if we look at what they say, complement theorem is saying it goes from being right angle to being complementary. The congruent complement theorem deals with the angles being congruent at the end. Okay, it deals with them being congruent at the end. Okay, so we have that congruent in there because they're congruent. If you don't see any congruence in here, we're not going to throw the word congruent in there. Okay, Gracie.
So the only thing that makes it a theorem isn't just a lot of words, but what it makes it a like definition is a lot of words to a lot of math.
Typically, definition will have a lot of words, a lot of math, and vice versa. Theorem can kind of have some of both.
So you just did.
I don't have an easy trick for theorems. I have an easy trick for definitions. Okay. Mason and McKinsey, number 6. What are we thinking? I agree entirely. That would be definition of perpendicular. Okay. Definition of perpendicular. Okay, and that's what the symbol means. Perpendicular, the upside down T. We went from two lines being perpendicular to having a right angle. Okay, and so this would be one of the few times where we didn't have a ton of math and a ton of work. Okay, so definition of perpendicular does say under definition that perpendicular lines form right angles. Okay, number 7. Okay, our trio back there. What do you guys have?
Definition of supplementary.
I would agree. Definition of supplementary went from a lot of words to some math, and we had supplementary in there. So that's the definition of supplementary angles. Very good. Okay.
It says postulates as well. Is there a trick in postulates?
The only postulate we know right now is the angle addition postulate and the segment addition postulate. So those are just standards. Okay. Number 8. Okay. Brayden and Marissa, what do you guys have? Congruent.
Yes. Oh, I'm reading it wrong.
Congruent complements theorem.
Very good. The congruent complements theorem. Okay. So this is where we use the congruent complements theorem. We have two sets of complements, and now the angles are congruent. Okay. Angle L and angle N are both complementary to angle M, so they're equal. They're congruent to each other. Okay. Number 9. What do you two have? Okay. I would agree that would be our supplement theorem. Okay. If two angles form a linear pair, then by our supplement theorem, they have to be supplementary. Okay. Number 10. What do you two have?
Complement hierarchy.
I would agree that would be the definition of complementary, okay? Because we went from some words to some math, that's a definition, okay? And we went from them being complementary to them having to 90. So we see that word complementary, so again, definition of complementary, okay? And I asked you boys to work on number 11, what did you guys get?
Angle, addition, post.
Okay, I would agree, angle addition post Malone, okay? Angle addition postulate there, saying, hey, we add up these two small angles, we get the big angle there. Okay. Now 12, I didn't have anyone assigned to it, but what do we think it might be? Went from two things being equal to them being congruent.
Proven.
What happens when we go from things being equal to them being congruent? Definition of congruence. Probably not. Okay, definition of congruence. Okay. Let's go ahead and flip this page here, please, and thank you, okay? So once again, like I said though, as we're flipping that page, the reference we went over first and the practice we just went through are big tools for you guys to use, okay? If you're stuck on our notes, if you're stuck on your homework, if you're stuck on your review, those things are really good to look at. If you're looking for something to study, those things are good to look at as well, okay?
Question mark?
No, okay? But it's a helpful tool to prepare, okay? I said that earlier, you can help me in on when's their test.
Yeah, we have a
Go to the next class, test when? Following Wednesday, very good, okay? So hey, we have this angle proofs guide in here, okay? It's the same thing as our segment one. It's the word bank for our first 6, okay? We're not gonna go through all 6, it's a word bank for them. We don't have them printed on here in line with it though. Like I said, that's a change I'm looking for in the future to do maybe next year. I'm gonna make myself a note to say, hey, maybe put in line with it. But for now, I went ahead and put it in the in my presentation on here, okay?
It's
So-
really think that you've only been here for 2 years because like the freshmen that were last year, like you're all that we knew.
Yes.
Like you know, so we
Yes.
didn't. Yeah, so it's weird
Yeah, that makes sense.
when you say that.
So, we have our left side statements. We're finding our right side reasons, and we have a word bank to do so. Hey, angle PQR is a right angle. We're given that this is a right angle, okay? And we're trying to find that angle PQS and angle SQR are complementary, meaning they add up to 90 degrees, okay? So to get there, what's going to be our very first reason? 100% of the time. Given. I'll put a percentage on that. It's 100% of the time that our first one's going to be given. Our first reasons always are given.
Oh wait, are
Okay.
did you just skip this page?
I talked about that as I went through it. That's a word bank we're using. We don't have to put it in line with it.
Oh.
So I put it right here though. On mine. On the slide. I don't have it on my paper, I have it on here. So now we went from it being a right angle to the measure equal to 90 degrees. Went from words to math.
Ha ha.
So it's probably a definition, okay? A definition of a right angle. Definition, words to math. And we look, oh, what words were we talking about? Oh, a right angle? Definition of a right angle. And hey, wait, does a right angle mean this at 90 degrees? Yeah, okay, so that makes sense too. Okay? So then we kind of take a slight turn. We say, hey, measure of angle PQS, it's right here, plus measure of angle SQR, add up to measure of angle PQR. We did the part plus the part equals the whole thing. What tells us we can add two parts to get the whole thing? Great.
Angle addition postulate?
Couldn't be more right. Angle addition postulate.
I thought that was the.
We have the same thing with segments, and we call it the segment addition postulate. When we do it with angles, it's angle. We do it with segments, it's segments.
Bible says segment addition postulate.
Ooh, you get though.
That's what I was thinking.
Yeah, so they're the same idea. They're an addition
I know.
postulate, where there's one's adding segments, one's adding angles.
But we had like graphs that looked like that.
Mm-hmm.
So I don't.
Not on our so they didn't have like arrows. They just had the segments. These are angles. Because these are rays. Okay. And hey, we see in our symbols here, Grace. We see in our symbols here a lot of angle symbols, telling us we're working with angles. So that's another way to kind of mentally make sure. Okay. I'm trying to. Yeah. Okay. So hey, now we're told measure of angle PQS plus measure of angle SQR equals 90 degrees. Went from equaling PQR to now equals 90 degrees. And I'd be okay with this being one of two answers, but here we only have one option for it. These are other options isn't listed. Okay? Went from these two stayed the same, but what changed? Now measure of angle PQR is 90 degrees. We're told the measure of PQR equals 90. So PQR is equal to both of these things. Now they're equal to each other. What tells us we can do that? Is that definition of complementary angles or the transitive property? Did we go from a lot of words to a lot of math?
Yeah.
Did we go from words to math? So is it probably a definition or not?
No, it's
Yeah.
true.
It's probably not a definition. Did we go from words to math from 4 to 5?
No, it's true.
Did we go from,
No.
okay?
It's the same. No, it's not.
Hold with me. From 4 to 5, do we go from math to words? Yes. So we're probably going to use a definition here. So if we're using a definition here, are we going to use a definition here? No, because we only have one left. So we're going to use our transitive property. Transitive property tells us, hey, both 90 degrees, stop, put it back.
Wow, I can't do it.
No, put
This
it back
guy
where it
was
was.
to be
It's more comfortable.
Okay, put it back where it was. Okay? Both measure of angle PQR and these two angles added together equal to, both 90 and these two angles added together equal to PQR. So now they equal each other. That's our transitive property, okay? I'd also be okay with us calling that substitution if we didn't have this word bank, okay? So now we went from math, an equation, to words. Okay, and what do the words involve? Complementary. So it's first of all probably what? A definition. And we're dealing with something being complementary, so the definition of complementary angles. Okay? Okay. Once again, please do not go through this mindlessly. Please try and engage your mind as we're going through this. You know it might be tough, okay? Engage. Okay? Question on this first one.
We're on the last page.
Let's go to the second one.
Wow.
So, voice it off, guys. Okay? Voice it off, please, and thank you. I appreciate you doing that. Okay? First reason.
Give it.
Every time. Give it.
Yeah, man. Mr. Titus said that only 95% of time is given.
This is the first one.
But so he might like not do it that way.
Yeah.
I'm just saying.
And here,
That's what people do.
and here, literally every first step is going to be given.
Great.
What?
I was
Oh, hey, Casey made a good observation. She said 3 is also given. And hey, we have a second given. Let's go and fill in 3.
Yeah.
So, sometimes, if you catch one, go and write it down. If you catch one, oh, I know what that is. Go and write it down, okay? So sometimes we have givens kind of in the middle, too. The first one will 100% of the time be given, and every now and then we have other givens, okay? So here, angle 1, angle 2 form a linear pair. That's part of our given information. Yeah, that
What if
Yes.
something is like, what if it says something like equals 180, but supplementary also means, like, what if it says blah 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 equals 180, and
Okay.
then in the proof or whatever it says blah 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 equals supplementary. With those,
That would not be given. You have to take a step to give it. And we'll actually see that right here. We'll see that right here, the step we would take, okay? So from 1 to 2, we went from these two angles, angle 2 and angle 3 being congruent, to now their measures are equal. What tells us we go from things being congruent to them being equal? Definition of congruence. Definition of congruence says, hey, we can go from them being congruent to equal or back and forth. Remember, I keep saying, if we start with them being congruent, we're probably going to change it to being equal right away. Big chance we're doing that, okay? So now we took kind of a left turn and said, hey, this one's given. Angle 1 and angle 2 form a linear pair, okay? So now we're saying, if they form a linear pair, that they're now supplementary. They form a linear pair, they are now supplementary, okay? Did we go from words to math or math to words?
No.
No, okay, so it's probably not a definition, okay? So, what might we be doing? What do we think? Check what theorem?
theorem.
It would be our supplement theorem. Supplement theorem says if two angles form a linear pair, they're supplementary.
Why do you get that little thing on the
I've explained that like 5 times.
Why do you get it become?
Okay, I don't have
He's
it on mine.
explained it.
I put it on there for all of us.
Oh, okay.
Okay, so because I need the extra help, Nolan, I don't have it. Okay, so how do we go from number 4 to number 2? Here we went from number 4, we had a lot of words. Number 5, we have a lot of
Words.
Numbers.
math. We went from words to math. So it's probably a definition, okay? So it's probably a definition that went from words to math. So if we're looking here, what words do we have? So it's probably definition of supplementary angles. Saying, hey, if two angles are supplementary, then by definition, they'd add up to 180 degrees.
Whoa, now.
Howdy, partner. Okay? So, from step 5 to step 2, hi, Dr. Mr. Carlson, nice to meet you. From step 5 to 6, what changed from step 5 to step 6? 2 and 3 were swapped out. Were we told their measures were equal earlier?
Yeah.
So how can we swap them out?
Substitution.
Substitution. And we like to put in our parentheses what we substituted, so please do that with me. Okay? That the measure of angle 2 is equal to the measure of angle 3, and that's the fact we used in
Wait,
order
why did
to
you put
substitute
C
that.
in front of M?
That's supposed to be a parenthesis.
Okay. I'll just,
I don't think you could have given me more sass than you look there than you tried.
well, you know,
Okay? I know you.
we learned how to
Okay?
draw a parentheses in like 2nd grade,
Yes, I probably need to go back.
1st
Okay?
grade, 2nd grade.
So from 6 to 7, we go from some math to what?
Words.
To words. So it's probably a definition. Okay? And what words are we talking about? So it's probably definition of supplementary angles. Went from them being adding up to equaling 180 to hey, they're supplementary. That's what that means to be supplementary. They add 180. Questions on that? Okay, here's what we're gonna do, guys. Okay? That's what you sound like. Okay? We're gonna go to number 9. Number 9. 9.
That's sounds like my nephew. Are we allowed to do that in school? Cause like,
What, the whole shining thing?
Oh no, say
No.
9 in German. Say 9 in German.
It's just no in German. It's
But it's like-
secondary because
but it's
German.
like,
I know what you're talking about.
German.
Okay? So on number 9,
like,
okay? Go to our very last page, we're looking at number 9. Okay? So we're given here
Yeah.
segment AB is perpendicular to segment BC. So what's our first reason always? Given. I never want to see anybody leave that blank or get it wrong. What? Okay. 7's also a given. Casey made another observation. Casey loves these givens. Okay. She says, hey, these are freebies. These are freebies. Let's do them. Okay. So 7's also a given. What else are we given? Angle 2 and angle 3 are complementary. So let's fill that in there.
Wait, but also, angle 1 is congruent to angle 2. It's
Well, that's what we're-
also given.
It's not given, but that's what we're trying to
Prove.
prove, which is why it goes in the very bottom left. It's proven. Okay?
Whatever.
No, we don't say fact. Okay? So, okay. So, angle BA or segment AB is perpendicular to segment BC. So we know that this angle is a right angle. Perpendicular lines make right angles. Mason, what was that earlier? Very good. Definition of perpendicular. Mason McKenzie had that problem earlier. That is definition of perpendicular. That is saying if two lines or segments are perpendicular, then they make a right angle. So this is a right angle. Okay?
If we say.
So,
That's definitely not 9 degrees.
okay? Okay. Let's just, we'll say it is now though. Because we're told it is. The picture might not be drawn on scale, right? It might have someone like Mr. Carlson drawing it, who's a bad artist. Okay? So,
Obviously.
now we're told our next reason is went for definition of a right angle. What does it mean to be a right angle? That it
90
measures
degrees.
90 degrees. So what are we probably going to put in our statement here?
AB equals.
Yeah, the measure of angle ABC, very good, is equal to 90 degrees.
Steal my thunder,
Okay,
dude.
good work.
We'll finish your sentences, brother.
Oh.
Ooh, get
That
wrecked.
was almost
Oh my
like
god.
Like just super calm.
Toasted,
That's
roasted,
how
and
Gracie
burned.
is though. Gracie's just like super low key and chill all the time. And so she's like, yeah, I'll just burn you though. Okay? So now we're told that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle ABC. This angle 1, this angle 3 adds up to the whole angle ABC. What's else we can take this part plus this part and make it the whole thing? Angle addition postulate. And we might see this as a little bit weird because normally we've been calling angles by 3 letters. Here we're calling them by numbers. We said back in chapter 1 you can do either. Okay? We're saying, hey, angle 1 and angle 3, that adds up to the whole thing here, okay? So now we're saying measure of angle 1 and measure of angle 3 are now equal to 90 degrees. We were told that the measure of angle ABC is the same as 90 degrees. So how could we get here? There's really one of 2 ways that I'm fine with either. Okay, we can call it substitution. And what would we substitute then, Clyde?
Measure ABC.
Yep. Equals what? 90 degrees, okay? Can somebody tell me the other way we would get there then if it wasn't substitution?
Transitive.
Transitive, very good. I'd be okay with either one of those, okay? If you're doing substitution, I need you to tell me what you're substituting. Okay?
What's more right?
Even. You're equally right. Okay, good question. Okay, so now we went. Our next reason is a definition. Definition is a big key mark that we went either from words to math or math to words. Right now we have math. So what are we probably going to?
Words.
Words, okay? And we're talking about complementary angles. So we're going to say angle 1 and angle 3 are
Complementary, right?
very good. Angle 1 and angle 3 are complementary. That's an and. Yeah, that's my and. Never mind, that's my and. It's not a plus, it's my and. That's why I do that little loop in there. Okay, so if you're ever wondering, is that a plus or an and? Mr. Collins wrote it, it has
That's
a
an
loop,
and.
it's an and. Okay? So, now we already have reason 7, or statement 7. Casey got that for us earlier. Say hands given. Okay, let's grab that.
Definition
Okay.
of congruency.
Right, we didn't go from equal to be congruent, okay? A lot of times it is our last one, but not this time, okay? What tells us that we had 2 complements, and now we have a congruent?
Right.
2 complements,
Right.
now we have a congruent.
Complement.
Close. What comes before it?
Congruent, complement, whatever.
Congruent complement theorem. Very good. Tells us that, hey, if both angle 1 and angle 2 are complementary to the same angle 3, they're then congruent to each other. Okay? Donkey? Okay.
No.
I don't understand that.
Hey, now what if this was too fast? Video. What if you have questions for Mr. Kossel?
What if Mr. Costle?
Before or after?
Before or after school, study hall, okay? If you really want to, guys, I'll be in the weight room today, tomorrow, and Thursday from 3:45 to 5. I have a student who said they're going to come in today and sit there and do math today. If you want to come in during that and do math, feel free to, okay? I will help you between supervising and between working out, okay?
I would like to see you as less as I can.
You know what? That's me.
Ooh.
She's back.
Oh, you can say it to me, but I can't say it to you.
I know, but I know that I'm joking, but I don't know if
I'm
you're
joking.
joking.
You're on house.
I love that song.
You're on house.
No, I am not dumb.
Yes.
He's so
Yes.
dumb.
Yes.
She reminds me of his girlfriend.
My house is right over there. Look at that. Probably see my house from.
No.
My favorite, actually, when I go here, you get the beer.
Oh my gosh.